Welcome to this CLEP College Algebra past paper revision. For professional exam preparation, tutoring, study guides, or assignment guidance, scan the WhatsApp QR code, message +1 716 356 9126, or email remote.exams01@mail.com. This video revises every unique question visible in the supplied paper. Question 1. The answer is 6x squared y. The numerical greatest common factor is 6. The smallest powers shared by every term are x squared and y, so the greatest common factor is 6x squared y. Question 2. The answer is 3. Multiplying powers with the same base adds their exponents. Since 8 equals 2 cubed, x plus y must equal 3. Question 3. The answer is 1/2 ln x minus 3 ln y. Use the quotient and power rules for logarithms. The square root of x contributes 1/2 ln x, and y cubed in the denominator contributes minus 3 ln y. Question 4. The answer is 6x plus 4y. This is a difference of squares. 36x squared minus 16y squared factors as 6x minus 4y times 6x plus 4y. Question 5. The answer is 16y squared. Inside the parentheses, subtract the exponents to get 2 times y to the 1/2 power. Raising that expression to the 4th power gives 16y squared. Question 6. The answer is -1. A negative number divided by its absolute value is always -1, therefore u equals -1. Question 7. The answer is the fraction x minus 5 over the product of x squared plus 25 and x minus 2. Multiply by the reciprocal of the lower fraction, factor x squared minus 4, and cancel the common factor x plus 2. Question 8. The answer is x squared minus 3x plus 9. Factor the sum of cubes. X cubed plus 27 equals x plus 3 times x squared minus 3x plus 9. Dividing by the length x plus 3 leaves the width. Question 9. The answer is the absolute value of y. Both numbers are negative and y is farther from 0 because y is less than x. Therefore the absolute value of y is the greatest listed number. Question 10. The answer is x squared plus 5x plus 2. Synthetic division by x minus 1 produces coefficients 1, 5, and 2 with remainder 0. Question 11. The answer is 18 times the square root of xy cubed. The square root of 4x is 2 times the square root of x. Multiplying by 9y to the 3/2 power gives 18 times the square root of xy cubed. Question 12. The answer is the fraction 2 minus 5x over x minus 3. Factor the numerator as 2 minus 5x times 2 plus 5x. The denominator factors as 5x plus 2 times x minus 3, so the common factor cancels. Question 13. The answer is the first and second expressions. Because x squared plus 4 is always positive, its absolute value equals x squared plus 4. The absolute value of negative x squared minus 4 also produces the same expression. Question 14. The answer is x minus 2y is at least 3, and 3x plus y is at most negative 1. The rising boundary is y equals 1/2 x minus 3/2, and the shading lies below it. The steep boundary is y equals negative 3x minus 1, with the shaded side satisfying 3x plus y at most negative 1. Question 15. The answer is 7/4. The quadratic formula gives x equals negative 5/4 plus or minus 7/4. Therefore, the absolute value of a over b is 7/4. Question 16. The answer is 12 days. After d days, the jars contain 104 minus 3d and 20 plus 40 pennies. Setting them equal gives 84 equals 70, so d is 12. Question 17. The answer is negative 1, negative 1, and 3, 7. Rewrite both equations as expressions for y and set them equal the resulting quadratic factors to give x values negative 1 and 3, producing the two ordered pairs. Question 19. The answer is negative 2 is less than or equal to x, and x is less than or equal to 5. Add 6 throughout the compound inequality, then divide every part by 2. This gives the closed interval from negative 2 to 5. Question 20. The answer is 0 is at most x is at most 2, and 0 is at most y is at most x plus 2. The region is bounded by x equals 0, x equals 2, the x-axis, and the line y equals x plus 2. Question 21. The answer is approximately 6.2 seconds. Set the height function equal to 0 and solve the quadratic. The positive root is about 6.19 seconds, which rounds to 6.2. Question 22. The answer is b to the 5th power. Subtract 58 and divide by 2 to get log base b of x equals 5. Converting to exponential form gives x equals b to the 5th power. Question 24. The answer is 1 plus the square root of 1 minus k. Applying the quadratic formula to x squared minus 2x plus k equals 0 gives x equals 1 plus or minus the square root of 1 minus k. The listed positive form is one solution. Question 25. The answer is ln k divided by ln 2. After n intervals, the population is 2 to the nth power. Solving 2 to the n equals k gives n equals log base 2 of k, or ln k divided by ln 2. Question 26. The answer is 5. The condition absolute x at most 1 means x ranges from negative 1 to 1. Then negative 3x plus 1 ranges only from negative 2 to 4. So 5 cannot occur. Question 27. The answer is 6. For no real roots, the discriminant must be negative. Here 16 minus 4c is negative only when c is greater than 4, and 6 is the listed value that works. Question 29. The answer is 6. Use the second branch for -2 to get 3, and the first branch for -3 to get 3. Their sum is 6. Question 30. The answer is 45. At -10, f equals 145 and g equals 100. Subtracting gives 45. Question 31. The answer is 1. The inverse of g of x equals x plus 1 is h of x equals x minus 1. Therefore h of 2 equals 1. Question 32. The answer is account R. By approximately $60. At 6 years, account R is about $203. Account T is $160. And account S is about $143. R is greatest and exceeds S, the least account, by about $60. Question 33. The answer is f of x equals -4x squared plus 5. This downward opening quadratic crosses the x-axis twice because its maximum is positive. The linear and cubic choices cross once, while the other choices do not cross. Question 34. The answer is f and h only. Function f has a constant difference of 3 and function h has a constant difference of 4. Function g doubles instead, so it is not linear. Question 35. The answer is c of x equals 1.05 times x minus 5. First apply the $5 coupon, giving x minus 5. Then multiply the reduced price by 1.05 to include the 5% tax. Question 36. The answer is the third graph, with vertex at -1, 0. Replacing x with x plus 2 shifts the original graph 2 units to the left without changing its shape. Question 38. The answer is 2. Because h is the product, h of 0 equals f of 0 times g of 0. Since e to the 0 is 1 and g of 0 is 2, the product is 2. Question 39. The answer is the multiples of 3.5 from 0 through 630. The integer input and ranges from 20 through 200. The profit equals 3.5 times n minus 20, so its values are multiples of 3.5 beginning at 0 and ending at 630. Question 40. The answer is 8/3. Write the quadratic as a times x plus 1 times x minus 3. The y-intercept makes it equal -2/3, and evaluating at the axis of symmetry x equals 1 gives 8/3. Question 41. The answer is g of x equals 2x plus 2. Start with y equals 1/2 x minus 1. Swap x and y, and solve for y. The inverse is 2x plus 2. Question 42. The answer is the interval from -2 to -1, union -1 to 1, union 1 to infinity. The square root requires x at least -2. The denominator cannot be 0, so x equals -1 and x equals 1 must be excluded. Question 43. The answer is the point 2, 4. The identity f of x equals f of negative x describes an even function. Its graph is symmetric about the y-axis, so negative 2, 4 is paired with 2, 4. Question 44. The answer is u equals b equals 1. If u is 1, the relation contains both 1, 4 and 1, 5. One input would have two different outputs, so the relation would not be a function. Question 45. The answer is 295. The first to third term increases 50 across two steps, so the common difference is 25. The eighth term is 120 plus 7 times 25, which is 295. Question 46. The answer is two distinct real values. The equation x to the fourth equals 16 has the two real solutions x equals 2 and x equals negative 2. The other two fourth roots are complex. Question 47. The answer is 9 minus 7i. Multiply the complex binomials and use I squared equals negative 1. Combining real and imaginary terms gives 9 minus 7i. Question 48. The answer is £450. The first six weekly amounts are 70, 72, 74, 76, 78, and 80. Their sum is 450. Question 49. The answer is x minus 3 times x squared minus 2. With integer coefficients, a root of square root 2 requires negative square root 2 as a conjugate root. Their factors combine to x squared minus 2, along with x minus 3. Question 50. The answer is 2n plus 3. The common difference is 2 because the sequence rises by 8 over 4 steps. Working backward gives a first term of 5, so the nth term is 2n plus 3. Question 51. The answer is 5 minus 3i. A complex conjugate keeps the real part and changes the sign of the imaginary part. Question 52. The answer is 10,000. The first factorial ratio is 102 times 101, and the second is 302. Their difference is 10,302 minus 302, or 10,000. Question 53. The answer is 64. The common ratio is 1/2. The sequence is 5, 1, 2, 2, 5, 6, 128, then 64. Question 54. The answer is only a b is less than a squared, because u is the more negative number. Multiplying b minus a by negative a shows that a b is less than a squared. The squared and reciprocal statements are not always true in the directions shown. Question 55. The answer is negative 1 minus I and negative 1 plus I. The quadratic formula gives negative 2 plus or minus the square root of negative 4, all divided by 2. This simplifies to negative 1 plus or minus I. Question 56. The answer is a sub n equals 3 to the power n minus 1. The sequence starts at 1 and each term is 3 times the preceding term. It is geometric with ratio 3, so the nth term is 3 to the n minus 1 power. Revision complete. Review any difficult questions and try them again. Keep practicing.